In our next series of examples, we're going to have to be a little more creative with our problem solving. In these examples, we're going to introduce some new strategies for the solving, plus looking out for some new operations that might be tying up the variable that we're trying to solve for. One of those examples is this question right here. This is the Pythagorean theorem made famous by Pythagoras and his school of followers. We are going to try to solve for the variable b, which is typically a representation for the leg of a right triangle. We see that with this b, joined together with this b, is this square, and then we're adding in this separate term. Similar to the examples in our last part of the lesson, we're going to invert and reverse all of the order of operations. Addition would be the last thing that would happen to b. So it will be the first thing that we eliminate when solving. So we will subtract a squared from both sides of the equation, leaving us with b squared equals c squared minus a squared. An interesting relationship in and of itself, but not solved exactly for the variable that we're looking for. We still have the concern of worrying about this too. If you think through all of your inverse operations, addition and subtraction, multiplication and division, the hope is that anything we do has a step that we're able to reverse and invert and get back to where we started. The square is no different. The square's inverse operation is the square root. So we can take the square root of both sides of this equation. This square root will eliminate the square that b was raised to and leave us with a final answer of the square root of c squared minus a squared. Now, if you're thinking to yourself that you would just like to call this c minus a, unfortunately, we're not able to do that. The square root is not a distributable operation. We can't send it to each of these terms individually and have them handled individually. Unfortunately for us, those terms are going to have to stay the way they are, where we have c squared minus a squared with a large square root over the whole thing. There will be times that we will be able to get creative with the square root later on in this course and maybe do some simplifying, but this is not one of those situations. The presence of that minus sign necessitates that we leave it alone at this point. In our next example, we have a very unique problem where the variable that we are attempting to solve for is in the denominator of a fraction. When you see the variable that you're trying to solve for in the denominator of a fraction, your primary responsibility should be to get it out of the denominator. It's very difficult to solve an equation for a variable when it is stuck in the denominator of a fraction, especially as we get more and more complicated. There will be times later on in this course where we start adding more fractions to this, and maybe we have something called a rational expression where there's some extra variables floating around. It's really in your best interest, if you see the variable that you're trying to solve for, to get it out of the denominator as quickly as possible. In this case, you have the option to change d to d over 1. If you were to do that, you now have a classic proportion, a fraction equal to another fraction. If that's the case, cross multiplication would be the way to go. D times v is dv, m times 1 is m. And I'd like to think at this point in the lesson that if this was the equation that you were handed, we would have no problem knowing that we're just going to divide by d, and we're left with v equals m over d. Resist the temptation when you're up here at the original question to just start flipping some fractions around. Use those skills that you've developed in previous classes and get to the point where you know the operations are going to behave the way you want them to. When you start taking reciprocals, flipping fractions over, changing numerators and denominators, unfortunately you create an extra set of problems and an extra set of issues that these questions are not equipped to handle. Our last example in the Getting Creative section, we're actually going to do it two different ways. One way, we're going to act as though we missed the fact that there was a parentheses, and the other way, we're going to follow the tried and true perspective that we've used for the last few. And I want you to see what this looks like as you approach this in two different ways. So the first way that we're going to do this is pretending that you just absent-mindedly made the decision to distribute. So you ignored all of the things we talked about inversing and reversing the order of operations, and you just made the decision to distribute. If you distributed the right-hand side in an effort to solve for f, this is what you would have got. You would have then followed that with the addition of 160 over 9 to the left-hand side. So we would have c plus 160 over 9 is equal to 5/9 of f. And then you would have the responsibility of getting rid of this 5/9. And you might remember from your previous class experiences, remember, keep using those skills you have. We can eliminate a fractional coefficient by multiplying everything by its reciprocal. So we're going to multiply the entire left side by 9/5, and we get this as our final version. If you aren't familiar with this formula, this is one of the most famous formulas in the world, let alone in algebra classes. This is the formula for converting between Celsius and Fahrenheit. It would be in your interest to have each version of this equation at least be familiar to you. But this is one way to solve it. So that's if I forgot that I shouldn't have distributed and I just distributed. Over here, I recognize the grouping symbol. I see that f is inside of it. I see that the 5/9 is on the outside. I'm actually going to start here instead with the 5/9. So we're going to multiply by 9 over 5 to get rid of the 5/9. And we're going to say 9/5 of c is equal to f minus 32. And then one move away, we're going to add the 32. See how much simpler this is. You're not messing around with 160 over 9s and all of that. And we get 9/5 of c plus 32 is equal to f. And you should, at the very least, ask yourself the question and convince yourself of the fact that these two formulas are identical to one another. They look similar. They have some similar pieces, but they're not, obviously not identical in their current state. But if we were to distribute over here, the 9/5 to the c and the 9/5 to the 160 over 9, we would end up with this version of the formula. Neither one of them is incorrect and neither one of them is correct. They both used good, honest mathematics in order to determine determine the formulas, but obviously this would be the better of the two options as it is the simpler of the two answers.